Hello, everybody. This is Nick Tiro, Professor of Information Technologies and Computer Science, Lakeland Community College. Now, if you were at Lakeland in the 1990s, especially probably 95 up to 2000, there's a good chance that it would be very difficult to get into some old programming classes, old COBOL programming classes. There was this thing called the Y2K problem, and it had to deal with, for 50 plus years, how they were storing dates in computers. They were storing dates at two-digit numbers. And in the 1980s, they said, well, wait a second, we got about 10, 15 years before we get rid of the 19 and have to replace it with the 2000. So if you're somebody like me who was born in 1963, my birth year would just be stored as 63. Well, what happens when the year 2000 comes around, 2001, 2002, all of a sudden the birth year is '01, '02. So this was a significant concern. Now, most organizations saw this concern coming early on. And really, for about 10, 15 years, they were putting through all the paces of rewriting code and stuff like that. But there was this genuine concern about Y2K. Fortunately, nothing happened. Well, they did a lot of work. So by the time it did roll over, nothing happened. There's another problem coming down the pike that you don't hear about, and that is the Y2038 problem. And it kind of triggered because I was doing some forensics, and a lot of times in log files and stuff like that, if those log files are associated with Unix or Linux, they're stored as what are called epoch numbers, or sometimes they call them, well, Unix time. And how this works is Unix and Linux stores dates and times as a 32-bit number. And it the Unix time starts on January 1st, 1970, and they just increment it by every second. Let's go up to my screen and let's take a look at the year 2038 problem. All right, just a little Wikipedia, and they got this little clock, countdown clock. Now, understand, Unix and Linux, a lot of them, the time is determined by a 32-bit number that gets incremented. That's what we're seeing here, by 1 second at a time, starting from January 1st, 1970. And we've been pretty good, but along comes 19th of January 2038, and we're going to run out of numbers. We're going to run out of that binary number, and there is a good chance that if people don't, hopefully people will fix this. We got what, 15 more years to go. This would cause a similar problem. Systems would potentially shut down. And when you consider that a good portion of the internet does run on Unix and Linux, it will be fixed. I'm not going to be the Chicken Little and say the sky's falling, but this was kind of interesting. And where this came from, okay, and if I just type date, it shows me the date. But I can get that epoch time. I can get the number of seconds from January 1st, 1970 to right now. So if I just say date plus %s, it shows me the epoch time. And if I do that again, you can see that it's incrementing a second for everything. So this is how internally this Linux machine is storing the date. So yeah, 15 years, it will be cleaned up. Now, the only reason I bring this up because I was working on some forensics files, and oftentimes they do store the files and logs and stuff like that, do store it as an epoch time. So I thought, you know what, let's take a quick look at it just for argument's sake. So if we go back, let's keep our fingers crossed that on 19 January 2038, we don't have any problems. That being said, you learned something. Let's go out and learn something.